so that we can handle your issue. So last week we did some bit of mathematics on indices and logarithms, and we did so many operations. We are going to actually use the concept in that I will keep on adding some students here. All right. So we did some indices and logarithms, and actually by the powers, that is the index and the logarithms, we are going to apply in our new topic today. Are you seeing my screen there?
Yes, you can see.
All right. So we're going to our new topic today, and our new topic is expansion. Our new topic is binomial expansion. And our objective is that at the end of this session, we should be able to define a binomial expression. We should be able to do expansion on binomial expressions. So actually, that's what I want us to learn at the end of this lesson. Now, let us find the definition of a binomial expression. We define a binomial expression from algebraic expressions. That a binomial expression is an algebraic expression. It's an algebraic expression containing two terms. Then that one we will call it a binomial expression if it has two terms. So pi means two and the norm means term. So two terms expressed together by either a plus or a minus, we say that is a binomial expression. Also, we have in general, we can express a binomial expression as a plus b to the power of n. N can be n number in the real number line. So in the real numbers, that is 0, 1, or of fractions, negative. So we say this is a binomial expression. Binomial expansion, let's look at what's a binomial expansion. Binomial expansion is the removing of brackets in an algebraic binomial expression. So when we look at our binomial expressions up here, you can see the brackets. So when we remove these brackets, actually we say we have expanded our binomial expression. Now let's look at some expansions so that we can be able to understand what we mean by binomial expansion. In our screen, you can see I've written something there very important, that in any binomial expansion, there is removing of brackets, and we make a new series of terms. You can see a table there. There is an expression, and we call it a binomial expression. That's that column. There's another column for an expansion, the number of terms, and then some remarks on the other side. Now, Cliff Aundo, you can put on your microphone so that you read for us the first expression.
A plus b raised to 0.
A plus b raised to power 0. Good. Wilberforce, when we expand that expression, what do we get in the second column? We are getting
okay,
what?
We have Malim, I'm not getting you very clearly.
Yes, Bana Wilberforce.
Thank you. We have a plus b raised to power 1. Malim.
Yes, I'm getting you. You can read for us the second expression.
Thank you. It's a plus b raised to power 1. When we expand it, we have A plus B.
Then how many terms are those?
There are two.
There are two terms. Thomas, I
There are
see
two items.
Thomas is with us. Can you read us the third expression? Who can help Thomas? Who can help Thomas to read for us the third expression?
Let me read.
Yes.
I don't know if you are getting it. Right. We have in equation 3, we have A plus B raised to power 2. When we expand it, we will have A square plus 2.
Yes, Wilberforce has gone to the air. Now we have the expansion is a squared plus 2ab plus b squared. Now we note that when we have our n being a 0, the number of terms is 1. So the number of the n value increases by 1 to give us the number of terms.
And we have 3 items there.
All right. So we can note that from our expansions, we don't see any brackets after we've done an expansion. Now, we want to look at the expansion of a plus b raised to the power of 1. We remove the brackets, that is, we open the brackets. What do we obtain? From our screen, you can see that we have a plus b. That is a plus b. So a is our first term. B is our second term. That's when we do an expansion of a plus b. What we actually get is a plus b. A is our first term. B is our second term. Good. Now, look at another expansion of a plus b to the power of 3. When we expand a plus b to the power of 3, we obtain a series of terms. And actually, that series of terms is equivalent to 4 terms. Because when you look at 3, what I'm highlighting here is 3, which is our n, is 3. So the number of terms will be plus 1. Will be plus 1. Will be plus 1. So we shall have 1 plus a cubed plus 3a squared b plus 3ab squared plus 1b cubed. So from our expression there, a cubed is our first term, 3a squared b is our second term, 3ab squared is our third term, 1b cubed is our fourth term. So we note something there. We have 1, 3, and 1. Those we call them are coefficients of the terms, and they are respective to the terms. 1 is corresponding with a cubed, 3 is corresponding to a squared b, another 3 with ab squared plus 1b cubed. We note that the powers of a are decreasing. When you look at there, you can see the powers of a are decreasing, a cubed, a squared, a0. So while for the b, they are increasing. The powers of b, they are increasing. You can see b 0, 1, 2, 3. Good. Now, let us do this example here. So we can see an example there that we're supposed to do in our class. Cliff Aundo. When we expand x plus y squared, we find that this one is similar to x plus y. You close the brackets, you open another brackets, x plus y. So when you expand you get that we have x multiplied by the second brackets. So we'll have this, then plus y, you multiply what's in the second brackets. Now we can open these brackets to obtain what? We obtain x squared, x times y, that's xy, plus yx, this xy, plus y squared, this y times this y. So we have x squared plus xy plus xy plus y squared. The ones that I've highlighted in red, you can see the ones in red, these ones, they are the same, they're like terms. So we shall obtain x squared plus 2xy plus y squared. So this is by polynomial multiplication. We can be adding our friends who have joined us. Some of our friends are joining us, so you can allow us to admit them. Good. Now, we are expanding an expansion there, x plus 3. So, when you look at that expansion, we obtain some terms together with coefficients. So that one is similar to when you multiply like the one we've done, x plus y squared, then you add another x plus y so that you make to the power of 3. So you can check on that, the first one we did, and then now we want to open by multiplying by with x plus y. So when you work out that one, you will find the first term, second term, third term, and the fourth term. Now, I want you, class, who can help us identify the first term in our expansion. Yes, Geoffrey Nyambane, can you read for us the first term in that expansion on your screen? So during your free time, you can do that class exercise. You do it and then you identify the terms, positions, and their respective coefficients. So what have we learned today? We learned the general polynomial expression to be a plus b to some power n, where n is some values of real numbers. We have understood that an expansion is when we remove the brackets from an polynomial expression. And all that is done through polynomial multiplication. So next time when we meet, we shall discuss about coefficients and how to find coefficients from Pascal's triangle. So I wish you all the best, and this is the end of our lesson today.